Professor Davis here with the sixth and final part of Essentials of Statistics, Computing and Interpreting Area Under a Curve. Well, that kind of sounds complicated. It's actually, I mean, in a way it is. It's really part of what's called integral calculus, but we're just interested for right now in computing the area under a horizontal line, under a constant function, so to speak. Well, that gives the kind of area of a geometric figure called a rectangle. And we all know how to compute the area of a rectangle, right? That's just the length times the width. So we want to apply that same idea to a function that's fixed over a closed interval, so to speak. All right? So we can use the same idea to compute the area under a constant function, f of x equals k, where k is a constant. There's no independent variable x here. And k is a fixed number, and the interval is from a to b. All right? So let's get an idea by taking a look at a graph what this formula would be. Well, let's see here. First, we need the height of this rectangle. That's the shaded area here. That would just be, well, from here up to here is what? K units, right? So the height is K. And then the distance between A and B, well, let's see, how would we get that? We would just take the right endpoint B and subtract off the length of the left endpoint A. So that'd be B minus A. So it looks like that gives us our formula then. The area of the shaded region here, in other words, under this constant horizontal function, is K times the difference between B minus A. All right? So let's try one of these, make sure we got the idea, and then we'll take a look at an application. Let's determine the area under the function f of x equals 1.5 on the interval from 1 to 5. All right? Okay, so here, k is 1.5, a is 1, and b is 5, right? So let's make a graph of what we're doing here. Here's our function, f of x equals 1.5. Here is a at 1. Here is b over at 5. Again, looking for this shaded region. All right, so we can just plug all those numbers into our formula here. So the width of the rectangle is given by 5 minus 1, or 4, right? 5 minus 1, that's 1, 2, 3, 4 units for the width. All right, and so to get the area of the rectangle, we take the width of it, which is 4, multiply it by its height, which is 1.5. And just to make sure, 1.5 times what? 5 minus 1. So what do we get there? 6. All right. So we get what? 6 square units for the area under that curve. Now, you might wonder why you'd want to do that. Well, the big answer for us in statistics is some probabilities are given by the area under a curve. Now, we won't be computing it by hand. We'll be using tables, and we'll be using statistics programs to find those areas. But we just want to get the idea of the concept of the area under a curve here. Now, let's take a look at an application now and see how we can use this with some real-life data. The consumption of iced tea and hot tea has gradually increased over the past decade. Now, I looked these values up from the U.S. Department of Agriculture and found that the annual increase in per capita consumption of tea in the U.S. from 2000 to 2012 is given by this function here. It's gradually increased, all right? The increase is gradual, and it's 1.2 gallons per year for the years 2000 to 2012. Notice how we have x determined here. X represents the number of years since 2000. So in 2000, x is 0. In 2001, x is 1, and so forth, till we get up to 2012, where x is 12. F of x represents the annual increase in tea consumption measured in gallons per capita. That means per person. So that's constant. That's increased constantly over this 12-year span. Now let's get to the question here. Use the function to determine the increase in per capita tea consumption just from 2007 to 2011 alone. All right, well, that's pretty easy here. So here we want to find the area under f of x equals 0.12, where k equals 0.12, and the values of x, They go from 2007 to 2011. So that's A being 7 and B being 11. Now let's draw a picture of this and make sure we get the idea. There it is right there. So here's f of x, that constant function. And then here's 2011 right here. That's our right endpoint, left endpoint 2007. Looking for this blue area, right? That'll give us that total increase in consumption between those 2 years. So here we go. K is 0.12, B is 11, and A is 7. 11 minus 7 is 4, so we get 0.12 times 4. That's 0.48. So let's think of what this means. From 2007 to 2011, the per capita consumption of tea increased by 0.48 gallons per year. In other words, during that time, on average, each person drank about a half a gallon of tea more each year. All right? So again, the idea isn't, we're not worried about tea consumption and that kind of thing. We're just getting the idea that the area under a curve has numerical meaning, and that's important to us for probability. So there you have it. That's essentials of statistics.